We have a problem, a huge problem, and that is, the emergence of AI and hyperscale data centers are growing beyond our ability to produce electrical power. The root of the problem, kind of get down on the micro scale here, the root of the problem is on your basic circuitry on the motherboard, okay? Everything communicates on the motherboard over copper traces. And as we continue to shrink the feature size down of these various processors, we need to have more and more bandwidth and shrink down the pitch count for the connectors into the processors. And we've reached a point where we just can't keep scaling down those connectors. And as you try to compensate by pumping higher data rates over copper, copper becomes more of a resistor than a conductor at higher frequencies. And so a lot of the power that is being consumed in these data centers, and especially some of this NVIDIA Blackwell AI processor, is in the copper interconnects. I mean, I was really kind of surprised to learn that the NVIDIA link and their NVIDIA switches, it's all copper-based. So the idea is, on a macro scale, we take fiber optics, right? It's used in telecommunications, extremely high bandwidth, extremely low energy consumption, and it's dynamic network. And we shrink that down into that chip scale, so now we can communicate between the processors and memory and other chips on and off the board over an optical network, over fiber, as opposed to copper. Photonics is one of the areas that looked at to be able to continue to shrink feature size and be able to provide the necessary bandwidth. To make photonics really feasible, you have to get the energy consumption down to 1 picojoule per bit. We took our technology that we had developed originally for other purposes, and in consultation with the National Security Agency and others, we developed these photonic links and architectures, and we can get our link down to 0.1 picojoules per bit. So not only do we meet the mark, but we exceeded it by a factor of 50. We've solved the physical layer issue, replacing copper traces and circuit boards with this transparent fiber network. So imagine we take this optical network, dynamic mesh network, and we can connect every memory chip, every piece of DRAM in this, not only just that motherboard, but the entire server, the entire rack, and across the whole data center, all stitched together to form a global coherent block of memory that each and every processor or GPU or whatever, FPGA, can connect to and read and write. Huge advantage for big data sets, large models and simulation. Certainly lends itself very well to artificial intelligence and neuromorphic processing.